This is Dr. Sridhar. Came back to you with another video lecture on how to solve electrical network with mesh analysis technique. So in this mesh analysis technique, how these KCLs and KVLs, Kirchhoff voltage law and Kirchhoff current law, we are going to use to reduce the complexity of given electrical circuit. Let us analyze this mesh analysis technique, which will be highly useful, and moreover it is very simple to reduce the complexity of electrical network further into a simplified manner. So I am going to take one simple electrical network having 4 loops here, 10 volts, and this is another 10 volts, 10 volts and 10 volts. And the sides are, this is 2 ohm resistance, this is a 2 ohm resistance, 2 ohm and 2, and these diagonal elements are 1 ohm each. Here the problem is, what will be the current in 1 ohm resistor using mesh analysis? So what is the resultant current in 1 ohm here, 1 ohm, 1 ohm and 1 ohm? What is the current here? So this circuit is nothing but the arbitrarily we have chosen to explain in a simplest manner and how the effectiveness of this mesh analysis in reducing the complex electrical networks into a simplified manner. So what is the current through 1 ohm resistance is we are going to determine, and we are making an attempt to simplify this electrical network. And again I am going to use Kirchhoff voltage law, and this law helps us, and this law mainly simplifies this mesh analysis. So what are the basic steps we had to follow in mesh analysis to reduce the complexity of the given electrical network? First of all, you have to identify how many number of loops are there. Just now also we have highlighted, now this electrical circuit is having 4 number of loops. So first loop and second loop, third loop and fourth loop. So this is first and this is second and this is third loop and this is the fourth loop. So there are 4 number of loops are there. That is our first step. And second step is nothing but give the mesh current direction. So arbitrarily you have to choose the current. Now generally to establish the current, now that current must and should find a closed path, then only it will find some magnitude, and that current will flow in the closed loop. So this is our first mesh current, this may be second mesh current, this may be third mesh current, this may be fourth mesh current. Here the important thing here we have to remember is, now the direction of the current is arbitrarily, either you can take in the clockwise direction or in the anti-clockwise direction, and only the my sincere appeal is you have to choose the direction of the current such a way that that current should not create should not increase the complexity of that electrical circuit. Of course, it doesn't matter in what way we are going to choose the direction of the current. It is very simple. Either you can take in the clockwise direction or in the anti-clockwise direction. So first step is identifying the number of loops, and second step is nothing but marking the mesh currents and identifying the number of mesh currents required to simplify the electrical circuits. And after second step and third step is nothing but you have to apply the KVL in every loop. So there are 4 number of loops are there. Now in the first loop, what is the KVL, and you apply the KVL and you have to simplify the electrical network. Similarly, that holds good for second loop, third loop and fourth loop also. And next one is, what are the unknown mesh currents? So here what we want to determine. So actually now they are asking us to determine the current in 1 ohm resistance. So that current flowing through 1 ohm resistance is unknown current to us. So that current you have to determine. So that is nothing but our fourth step, find the unknown mesh currents here. And last one is find the unknown value. Suppose in some of the cases what happens, people want us to calculate what is the voltage drop across any one of the resistor by using mesh analysis. In such cases, the voltage drop across any resistance are not only through 1 ohm resistance. Suppose if anybody wants us to calculate what is the current in this 2 ohm resistance, then again that is also one of the unknown parameter. So at the end we can calculate the unknown parameters with the help of mesh analysis. That is our fifth step. So slowly, let us make use of these 5 steps and let us determine the mesh analysis, and let us determine what is the current flowing through 1 ohm resistance with the help of this mesh analysis. So identify the number of loops. So loop 1, loop 2, loop 3 and loop 4. There are 4 number of loops are there, 1, 2, 3 and 4. And second step is give the mesh current direction. So I am choosing arbitrarily. So this is the mesh 1. So clockwise direction of current I have taken, and this is our mesh 2. Here also we have taken the clockwise directional current, and third one is also a clockwise directional current, and fourth one is also a clockwise directional current. So like this, now if you are not convenient or if you are not comfortable with this clockwise direction, at any time some of them may be taken as a clockwise, some of them may be taken as anti-clockwise direction also. That is up to you. That is based on the student or faculty who is going to solve this particular problem. That is up to us. And third one is nothing but apply the KVL in every loop. Suppose if you are taking here in this first loop, what happens? There is a 10 volts electrical source is there. This is plus and minus, and this is 2 ohm resistance, and again this is 1 ohm resistance, and here this is also 1 ohm resistance. Here the simple thing you have to remember is this 2 ohm is nothing but the current flowing through this 2 ohm resistor is only the current in the mesh 1, that is I1 current. But here in this 1 ohm resistance, what happens? This mesh 1 current is coming like this, but mesh 2 current is going in the upward direction. That current is nothing but the I2 current. I mean to say, now in this 1 ohm or through this 1 ohm resistor, there are 2 currents. One current is moving in the downward direction, that is I1 current. Now this is the I1 current, and next current is nothing but this is the I2 current. So whenever you are applying the KVL to know the drop across this 1 ohm resistance, that will be, or the drop across this 1 ohm, it will be contributed by 2 currents, that is I1 current and I2 current. So that is the important thing we have to remember. Of course, we are taking individual loops, but in the individual loop, the common branches you have to pay a little bit attention while calculating the drop across that elements. Similarly, this is one more 1 ohm resistance is there, and this is shared by loop 1 and loop 3. So loop 1 current is nothing but, now see, this is coming from right to left. So this is the I1 current. But when as I3 current, it is coming from left to right. So this is I3, I1 and I3. So if you are applying KVL in loop 3 or loop 1, either in loop 1 or loop 3, so more cautiously you have to take care of this current's direction. So the drop contributed by this 1 ohm resistance is nothing but I1 minus I3 if you are applying KVL in the loop 1. That is I3 minus I1 into 1 ohm. Now if you are applying KVL in the third loop. Means in which loop we are particularly applying KVL. So for that loop current, we had to give the priority. So that is the one important thing we had to remember while applying KVLs for individual loops. So first one is across this 10 ohm resistance, that is a 10 ohm value, and across 2 ohm, only just now we have discussed that the drop of this 2 ohm is nothing but only I1 into 2. And next one is the drop across 1 ohm is nothing but I1 minus I2, because this 1 ohm is shared by mesh 1 and mesh 2. So I1 minus I2 into 1. 1 is nothing but that is the resistance value. And through this resistance, how much of current it is flowing? I1 current is flowing and I2 current. I1 is coming in the downward direction. I2 is moving in the upward direction. So the resultant of the current is I1 minus I2 into 1 ohm. Similarly, across this another 1 ohm, this 1 ohm resistance is shared by loop 1 and loop 3. So the current values are nothing but the I1 minus I3 into I1. Because why we have given priority for I1 positive means because we are working in the loop 1. So let us give the priority for that particular current I1 minus I3 into 1. So this is the KVL of the loop 1. So similarly for the loop 2, 10 volts, and this I2 minus I4 into star 1. So this is star is nothing but it is a product between, because this resistance, this 1 ohm resistance is contributed by the second loop and fourth loop. So second loop current is I2, fourth loop current is I4. So I2 minus I4 into 1. This is the contribution of this 1 ohm in this KVL of second loop. So second one, here you see the beauty of this 1 ohm resistance. Whenever we are applying the mesh analysis or KVL for this loop 1, we have given the priority for I1, and whenever same across the resistance 1 ohm only, we are attempting to find out the drop across this 1 ohm. So that is I2 minus I1 into again the resistance value. So last one is across 2 ohm, that is I2 into 2. Similarly, third mesh 10 volts, and this is I3 minus I1 into 1 and I3 minus I4 into 1, and this is solo contribution of the third mesh, so I3 into 2. So coming to the fourth mesh, 10 volts, and this I4 into 2, and then I4 minus I3 into 1, then I4 minus I2 into 1. So these are the individual drops and voltages across various passive and active elements. So finally, with the help of KVL's Kirchhoff voltage law, that statement, that is nothing but the resultant voltage drops in any closed path is nothing but the 0. So for first loop, minus 10 plus I1 into 2, that is the contribution of this first is 2 ohm resistors, then I1 minus I2 into 1, and then I1 minus I3 into 1 is equal to 0. So that is about the KVL of the first loop, and this is second loop, third loop, and the fourth loop. So these are algebraic expressions. These are the mathematical equivalent of individual loops, and we have derived this mathematical equation with the help of KVLs, or by applying KVLs for individual loops. Now we arrive to 4 mathematical expressions. And next one is find the unknown mesh currents. So what are the mesh currents here? First mesh current is I1, second is I2, third I3, and fourth I4. So we have 4 mathematical expressions, and all these 4 mathematical expressions are nothing but it depends on mesh currents I1, I2, I3, I4. So with the help of some algebraic computations, let us determine the mathematical values of I1, I2, I3, I4. So if you are simplifying our previous KVL expressions of individual meshes, so first expression looks like 4I1 minus I2 minus I3 is equal to 10. Similarly, second, minus I1 plus 4I2 minus I4 is equal to 10. Third one is minus I1 plus 4I3 minus 4I4 is equal to 10. And last one is minus I2 minus I3 plus 4I1 I4 is equal to 10. So these are the simplified expressions of the loops KVL expressions. So if we are simplifying these 4 expressions by adding or subtracting, so we are going to get I1 value, I2 value, I3 value, and I4 values. And of course, the resistances are same. Almost majority of the resistance values are 1 ohm, and 4 resistors are having 2 ohms. So luckily what happens, the I1 value, I2 value, I3 value, and I4 values look same. That is 5 amps current. So next point is find the unknown values. So what they are asking us to find out here, what is the resultant current across 1 ohm, 1 ohm, 1 ohm, and 1 ohm. There are 4 1 ohm resistances are there. So what is the equivalent values? So this is the last step, because this is the point where we are going to determine unknown values across or through the desired resistor. Here desired resistor is 1 ohm resistor. So they are asking us to determine what is the current here. Now current at each 1 ohm resistor, or current through each 1 ohm resistor is, now through this 1 ohm resistor the current is I1 minus I2, and through this 1 ohm resistor is current is I1 minus I3. Current through this 1 ohm resistor is I2 minus I4. Current through this 1 ohm resistor is I3 minus I4. So that is I1 minus I2, or I2 minus I4, or I3 minus I1, or I4 minus I3 is equal to 0, because the current values are I1, I2, I3, I4 are nothing but the 5 amps current. So this problem helps us to determine mesh analysis. Thank you for watching this video. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.